Polymers can be classified in many different ways based on the entity or characteristics under consideration. However, the most common classification of polymers are based on source, structure, mode of polymerization, and molecular forces. Classification based on source. This classification groups together polymers that are derived from the same source or set of sources. We can further group them into three different subcategories, namely, natural polymers like proteins, starch, cellulose, resin, rubber found in plants and animals. Semi-synthetic polymers like rayon that are synthesized from natural sources, and synthetic polymers such as plastic, synthetic fibers, synthetic rubbers that we use extensively at home and in industries. Classification based on structure. In this classification, polymers are grouped together based on their relative structures. Thus, polymers can be linear polymers that are long and straight-chained, branched chain polymers which are similar in structure but for the fact that they have some branches too, and cross-linked or network polymers that are formed from bifunctional and trifunctional monomers and contain strong covalent bonds between various linear polymer chains. Classification based on mode of polymerization. Under this classification, we group polymers on the basis of the chemical reaction or the process that the constituent entities undergo to form the required product. The two major categories under this classification are addition polymers and condensation polymers. Addition polymers. As the name suggests, addition polymers are formed by the repeated addition of monomer molecules possessing double or triple bonds. But again, this addition is also of two types. Let us see what they are. Homopolymers. As we know, homo means similar. The addition polymers formed by the polymerization of a single monomeric species are known as homopolymers. The formation of polythene from ethene and polypropene from propene are both examples of addition polymerization of monomeric species. Copolymers. The addition polymers made from two different monomers are termed as copolymers, the most common examples being that of Buna-S and Buna-N. Condensation polymers. Condensation polymerization involves repeated condensation reaction between bifunctional and trifunctional monomeric units. However, it differs from addition polymers in the fact that the process leads to elimination of various byproduct molecules like water, alcohol, halogen acids, etc. Hexamethylene diamine with adipic acid. As an example, let us consider the formation nylon 6,6. It is formed by the condensation of hexamethylene diamine with adipic acid. Classification based on molecular forces. The application of various types of polymers in different fields is largely determined by their unique mechanical properties like tensile strength, elasticity, toughness, etc. These in turn are governed by the intermolecular forces like the van der Waals forces, hydrogen bonding, which we have already studied about in our previous chapters. These molecular forces also bind polymer chains together. Thus, it is necessary to further divide polymers into subgroups based on the magnitude of these molecular forces. Elastomers. Yes, elastomers are called elastomers because they are elastic. For example, rubber. However, the polymer chains in elastomers are held together by the weakest of intermolecular forces, sufficient enough to stretch them. A few cross-links are added in between the polymer chains that enable them to retract to their original position. But this is true only when the force applied is within the elastic limits. Common examples are Buna-S, Buna-N, neoprene. Fibers. Fibers are thread-forming solids which possess high tensile strength and high modulus. Their strength is derived from the strong intermolecular forces like hydrogen bonding and hence lead to close packing of chains. Strong bonding plus closed packed chains are a formidable structure and thus define their crystalline nature. Thermoplastic polymers. Before learning about thermoplastics, let's take an analogy. Imagine a lit candle in the shape of a cylinder. This candle is placed in a bowl-shaped vessel. As the candle burns, the wax melts and gets collected in the bowl. On cooling, the wax takes the shape of the bowl. This wax can even be reheated to obtain molten wax and is then free to take any other form. Similarly, thermoplastics are a type of plastic which melt and turn into molten liquid on heating. When they are in liquid state, they can be molded into any kind of shape. Imagine pouring the liquid plastic into a mold that is bucket-shaped. On cooling, the plastic solidifies and we get our very own household bucket. This bucket can give us the original plastic back on heating. Such plastics which can be heated and given any form again and again are known as thermoplastics. Thermoplastic polymers are the linear or slightly branched long-chain molecules capable of repeatedly softening on heating and hardening on cooling. They possess intermolecular forces that are greater than elastomers but less than those in fibers. Thermosetting polymers. Thermosetting polymers, like thermoplastics, can be given any shape after they are heated. Once set, they cannot be melted again. If they are exposed to excessive heat, they become brittle and could form cracks. And thus, as they become infusible and heavily branched, they cannot be reused. Some common examples are bakelite, urea, formaldehyde resins, etc.